Hello and welcome. I'm Vasco from the Angular University and you are very much welcome to the Angular for Beginners course. This course is being continuously updated to the latest version of Angular, so be sure to check it once in a while again to see if there are new changes. We are going to learn Angular by diving straight into it by doing small examples while we introduce the multiple functionalities of Angular core. So we will be covering in this course the Angular core library. That includes components, directives, services, modules, and pipes. That is essentially the content of the Angular core library together with its dependency injection system. We are also going to learn how to debug Angular applications. We will also be covering the Angular CLI at the end of the course, but right now we are going to use a beginner-friendly playground that uses a very simple HTTP server and gives you a save and refresh simplified development experience that will simply just work, so you will not run into issues because some server is running or it's not running anymore on the background, etc. It's a very simple playground with minimal dependencies, so it's ideal for getting started with the framework. So without further ado, let's start learning Angular. We are going to start by installing the beginner's playground right now in the next lesson. Again, I want to thank you so much for enrolling. I hope that you will enjoy the course. Any issues or questions about the installation or anything else, please let me know in the comments. And without further ado, let's start learning Angular together. Hello everyone and welcome. This is the second part of setting up your development environment. We showed you how to install a blank development environment. Well, it's just as simple to install the lessons code. It's the same steps. We just need to go to a different GitHub repository, the one that I'm showing here. We go to this repository and again we download it as a zip file. We unzip it and we cd into the directory. And once again we do the same steps. npm install, it should take a couple of minutes to install everything, and then npm start. The port where the lessons code runs is fixed, so if you run into port conflicts, you can modify the port in this lessons-server.ts file. In this line here where you see app.listen and then a port number, that's the port number of the lessons code. And with this, your lessons code is running. If you go to port 8082, you will see that you have multiple examples to choose from. If you click in one of them, you will be taken to a live example that was part of one of the lessons in this course. Now, I really encourage you to try things along using either the blank starting point or the lessons code as we go along. But having said that, if you are watching the course on mobile and you cannot run the lessons code, I assure you that the course still makes perfect sense if you don't try the code along as we go. But if you have the opportunity, I really encourage you to try things out as we go along. You will see that that's a better learning experience. And now, without further ado, let's get started building our first Angular 2 application. Hello everyone and welcome. Vasco here. Let's get started with the Angular for Beginners course. We are going to be using this Angular 2 for Beginners starter repository. Let's see what the starter kit contains. So it's a very simple repository that will allow you to develop Angular in a save and refresh development environment, a stable development environment made to be beginner friendly. So in order to install this repository, we simply go here to the clone or download button of GitHub and we either download it as a zip file or we clone it by copying it to the clipboard. Once the repository is installed, you can switch to your integrated development environment of choice, such as for example WebStorm. In this course, all the lessons will be recorded using the WebStorm IDE. We can download it here, there is a free 30-day trial, or you can also use the Visual Studio Code editor from Microsoft, which is free. So once you have downloaded the repository or you have cloned it, you can switch to your IDE and you should have something like this. You will have here a structure where you have here an app.ts file. This is the file that we will be editing in the next lesson. So we are going to create our first component from scratch. So the code that is here, you can delete it in preparation for the first lesson. Meanwhile, what we will do is we will install the dependencies that we need to get started with the course. So if you switch over to the terminal, you need to have node and npm installed in your machine. You simply do npm install at the directory where your repository is, where your package.json is. This is the directory where you should type this command npm install. Once the dependencies are installed, we can quickly start the repository to make sure that it's running okay. So I will simply put back here the code that says hello world for a moment just to test the repository. If you want to do the same, you can do npm start and this will start a development server. And please notice carefully your console. You will have here the port where your server is running. So if by any chance your port 8080 is occupied, this will be started on port 8081, 8082, etc. So it's important that you confirm here that the port that you are actually running is 8080 and not some higher number. Now, in order to confirm that the development server is working, you simply head over to your browser and you type localhost 8080 in this case, and you should have here the hello world message printed to the console. So this shows that your installation process is correct and that you are ready to continue the next lessons of the course. If at this stage you find a problem, please put it in the comment section so that I can get back to you. This is especially important in this early stage of the course where you are setting up your development environment. So any error messages that you might find, please put them in the comment section so that we can address those. You are very much welcome to the Angular for Beginners course. Let's get started by building our first Angular application. Before doing that, let's quickly go over questions in the comment section. How can we use the comment section to learn the most on this course? We are going to quickly go over that in the next lesson and then straight to building an Angular application. I want to thank you for enrolling and I hope that you will enjoy the course. So without further ado, let's get started. Hello everyone, how's it going? Vasco here from the Angular University. Welcome! Before we start the course, let's talk a little bit about questions. So, if you ask questions in the comments section, I will provide support. Before anything else and about the questions, I really encourage you to try to answer each other's questions because many times it's a simple npm install issue or it's simply a port conflict, something to do with Windows installation. These problems happen frequently and if you might know the answer for it because you just had it a moment ago and you know the answer, I encourage you to please post the answer. Please don't hesitate to participate in the discussion. Every question is a good question. Every answer attempt provides an opportunity for learning. So please don't hesitate to post the answer that you believe is correct. This would bring to all of us several advantages. So you would get a faster answer for the most frequent questions. It would give you an opportunity to practice the technical skill of providing technical answers to other developers, and of course it would allow me to scale better because I would have less answers to provide to, and I would still be reviewing the answers, of course, to make sure that everything is correct. Most of all, I would like to encourage discussion in all its forms. Please feel free to post the questions that you have, feel free to post answers, comments on other people's answers. Your contribution to the question and answer section in all its forms is very much welcome. Now let's talk a little bit about how to ask a question. I encourage you when you ask the question to try to post some code to go along with it. it really helps to understand better what is going on. So, not a lot of code. It's important to try to reduce the question to its minimum essential. It's a great thing to do because you will notice, and I have seen this many times over the years, when you start writing the question, if you try to summarize the problem to its minimal form, many times you will actually find the answer while writing the question. It happens to me all the time. Having said this, posting code is not mandatory at all to ask questions. Some questions don't need code, so use your own best judgment of what is the best way to ask the question. Remember, asking technical questions in forums, it's a great technical skill to develop. It's a skill on itself. I want to repeat that every question in this forum is a good question. If you have a question, go ahead and ask it the best way that you can. If you happen to know the answer, please provide the best answer that you can. If it's not correct, it's not a problem. We are here to learn. I want to thank you so much for your contribution on the question and answers forum, and let's start learning Angular together. Thank you for watching. Hello everyone and welcome. This is Vasco from the Angular University. And in this lesson we are going to build our first Angular 2 application from scratch. So let's get started. The first thing that we need to do is define our root component. Let's define a class named app. This will be the entry point of our application. We need to annotate it with the @component annotation. And inside the @component annotation, we need to pass in a JavaScript object that contains two mandatory properties. One is a selector, so this is a CSS selector that will define to which HTML elements in the page this component gets applied to. We're going to give an example of such a component in a second. The second mandatory property is the template property. We need to specify either a template or a template URL. We will see that in a future lesson. Right now, let's define an inline template, which simply prints a message to the screen saying hello world. How can we use this component that we just created? What does this look like in terms of HTML? If we see here the HTML of this page, we are going to add to this page a custom HTML element named app, which Angular will associate via the app selector to our component. And so it will replace the content of this custom app tag by the message hello world. And this is one of the most powerful features of Angular 2. We can create our own custom HTML elements. What we need to do now is to start our Angular 2 application. We need to bootstrap it, to use the framework's terminology. So to do that, we have several ways of doing it. The recommended way of doing it in development mode is to use the Platform Browser Dynamic Bootstrap Module method. So what this takes is an Angular 2 module definition, which will be used to bootstrap the application. So what is an Angular 2 module? We are going to go into modules in detail later in this course. Right now, for us, it's enough to know that the module is a way of grouping related Angular 2 functionality, grouping related components, directives, pipes, and services in a single logical unit. Our application has one root module. Let's write it. So we just need to define a class that by convention should be called app module, and we are going to apply it the @ngModule annotation. Inside it, we are going to pass it a configuration object. In this configuration object, we need to define which components this module recognizes. And we're going to add in, of course, our app component, the root component of our application. We also should specify which is the entry point of the application, because we could have many components that are recognized by this module, but we haven't told Angular what is the entry point of our application. In this case, we are going to configure it via the bootstrap property, and we are going to say that our root component is the app component. So we pass in this module to our bootstrap call, and we should have a running application, right? Let's give it a try. If we now try this out, we can see that we have here an error in the console. Why is that? That's because we have not imported the browser module that contains all the core Angular 2 directives and much more. If you are developing a web application that is going to run in a browser, we should import the browser module. If we are running in other environments, such as for example native mobile, we would have another module that would replace the browser module. For the moment, let's include it and see what happens. If we now try this out, we can see that our first Angular 2 application is up and running. Summarize, each Angular 2 application is a tree of components, and there is usually only one root component. We need to specify a root bootstrap module that we need to pass to our bootstrap function. This module will declare which components this application recognizes, what are the components that make up this application. What we do here is we can import them one by one in the declarations property, or we can import them together with directives and pipes and services as groups of related functionality named modules, and we can import modules in the imports property of the module declaration. If we are building a web application, we need to import browser module in our root component only. We should not import it elsewhere in the application. We need to tell the application what is its entry point. There could be several. Actually, notice that the bootstrap property is an array. But in most cases, there is only one entry point for the application, the root component. What we're going to do now is we're going to write our first non-root component. We're going to add a visual component to our application. It's coming right up in the next lesson. Hello everyone, how's it going? It's Vasco from the Angular University. And in this lesson, we are going to write our first Angular 2 component. Let's build a very simple widget, a search box widget, which contains an input box, and next to it we have a button to clear the input box. So let's get started. What we really want to do is we want to define an extra HTML element to the standard HTML elements that a page might have. We want to create a search-box HTML element, and we want to be able to use it in our application just like it was a normal HTML element. So how can we do this? We define an Angular 2 component. We define a class, let's name it simply searchbox. We are going to annotate it with the @component annotation. Again, this tells Angular that this is a component. Inside the configuration object, we are going to define a selector. The selector needs to match the HTML element name that we are going to use, in this case search-box. So by convention, the CSS selector that we apply here in a component should be an element selector. We should not, for example, use property selectors here. What we need to do also is to define a template for the component. What will the component look like visually on screen? A component might use other components. In this case, we are just going to add an input box to the component, and next to it we are going to add simply a clear button. And there we have it. We have a very simple component defined. In the upcoming lessons, we are going to see how to add behavior to this component. But right now, we just want this HTML to be displayed on the screen in place of the search-box component HTML tag. To do that, what we can do is we can try to run the application like this. What will happen is that nothing will be displayed. This is because the application is not aware of the search-box component. Nowhere in our application we have configured this component. We need to do so by adding it to the module definition of our application. In this case, because we only have one component for the moment, we are simply going to add it directly in the declarations property of our root module. If we try to use this component again, if we reload the page, we can see that our component is now working. In the next few lessons, we are going to add behavior to this component. Namely, we are going to pass it inputs and we are going to receive outputs out of it. So stay tuned because it's coming right up. Welcome to a lesson of the Angular University. In this lesson, we are going to learn about component inputs. If you already know component inputs, in the end of this lesson, I'm going to share a way of abbreviating certain situations where we are passing input to a component. So you might not be aware of that. So let's start with a simple example straight away. This is a search box component. It has an input box and a clear button. Now, let's say that we want our placeholder text. We would like this not to be constant, but we would like to take it from a variable that is part of our search box component class. Let's do that. Let's define a variable. Let's call it text, and we are going to assign it the text that we want. Now, how do we output this to the component template? We're going to use the interpolation syntax that we are going to cover in more detail in a future lesson. Right now, we are just going to output the value of a string into the template. This double curly brace expression is an interpolation expression, so the double curly brace is recognized by Angular and tells it that the content inside the double curly brace is an expression that Angular should evaluate by taking as context the component itself. So if we, inside double curly braces, we output text, that will be taken from the search box component. Let's try this out. If we now reload the page, we can see that the placeholder is type your search as expected. Now, we would like to take this one step further. We would like to make the placeholder text configurable by any other component that is using the search box component. For that, we need to make the variable text an input of the component. And we can do so by annotating it with the @input annotation. And notice the parentheses at the end of the annotation. Without this, the annotation will not work. Now, one thing, we don't want the input that is passed to the component to be named text. That's just an internal name for an internal variable. We want the input to be named placeholder, like the standard HTML attribute. So now, how do we use this input? How do we pass in an input to a component? So we go to the component that is using search box, in this case our root component, and we are going to pass it in a placeholder input variable. We do so with the angle brackets template syntax notation. This is the template syntax notation for inputs in Angular 2 components. We are going to pass into the input variable placeholder, we're going to pass it in a string. The goal is that this string overrides the default value of the text property inside the search box component. So let's try this out to see if this works. As we can see, we have custom placeholder displayed correctly as expected. So the input property is working. Now, you might think that this is a very common use case to pass a constant string as an input. Yes, it's true that in certain situations this might be a dynamic property, but in this case, let's say that it will always be constant. In that case, this syntax that we have here is slightly verbose. For this particular case, where we are passing in a constant string to an input property, we have an abbreviated notation syntax that we mentioned in the beginning of the lesson. If we remove the quotes around the strings and if we remove the square brackets, this will still work. So let's give it a try. As we can see, everything is still working and this looks like just a plain HTML attribute. This is much more readable. It actually looks like a plain HTML attribute, which is also more intuitive for someone looking at the template. What we're going to do now is we are going to add behavior to this component. We are going to When the user clicks the clear button, we are going to clear the input box. So we are going to learn the template syntax for events in the next lesson, which is coming right up. Hello everyone and welcome, this is Vasco, welcome to the Angular University. In this lesson we are going to learn about component events and event emitters. So let's get started. What we're going to do here is we're going to take this simple component, which is the search box component, which has an input and a clear button. We're going to implement the clear button behavior. So what we want to do is whenever we type on the input search box, when we click clear, the clear button, the input box should be cleared. So how do we handle this? Let's use the events template syntax for this. So what we want to do here is in the element where the click occurs, so the button, we're going to add a click handler and we're going to use the rounded parentheses or normal parentheses for this. This is the template syntax for events in Angular 2. Both browser events and custom events, as we will see in a moment. Now, inside the rounded braces, we are going to type the, in this case, browser event to which we want to respond to, in this case, the click event. On the right hand side, we are going to define how this event should be handled. In this case, we want to call the clear component method. Let's implement this method by simply adding a call to log to the console. Let's try this out. If we now type in something and we click the clear button, we can see that our statement is logged to the console as expected. Now let's talk about how could we implement the clear behavior. Well, one way to do it, let's do it first in plain JavaScript. So let's select using the Chrome DevTools, we're going to right click on the input box and we're going to inspect it in the HTML panel. If we now switch back to the console, the $0 variable contains the last element that was clicked while inspecting this on the DevTools. So in this case, $0 is the DOM element of the input box. How can we clear this? We can clear it by assigning it a value of an empty string, for example. So if we do $0.value equals empty string, this is an example of how to clear the input box. So let's implement this in Angular 2. Let's now implement the clear behavior. So what we want to do here is we want to introduce a new concept besides events. We want to introduce the concept of references. So we can assign a template reference using the hash character and we are going to give it a name to the input box. We are going to call it hash input. So whenever inside the template we refer to input, we are referring to the DOM element of the input text box. So now we can pass it in as a parameter inside the clear method, for example. Now, what we can do inside the clear method is we simply assign it a value of an empty string, and this will clear the input box. Let's try this out. If we now type in the input box and we hit the clear button, we can see that the input box is being cleared as expected. Now we have seen how to use the template syntax for events. In an upcoming lesson, we're going to see how the same syntax can be applied to custom events. We will first learn how to externalize the templates of our components and how to apply CSS styles to our components. Then we are going to tie everything together in a more complex introduction to components example where we are going to have multiple components interacting with each other and using custom events using event emitter. So stay tuned, all of this is coming right up in the next lesson. Hello everyone and welcome, this is Vasco from the Angular University. And in this lesson we are going to learn how to externalize component templates in an external file. We are going to learn the best practices recommended by the official style guide for that. So let's get started. We have here a very simple component with an inline template defined using the template property in the component annotation. Defining templates inline, it's usually okay when we are trying out something, or maybe if your component is a very small component. But in general, we really want to separate the template into an external HTML file. So let's do that. Let's extract the HTML template from the component and let's create an external file which has the same name as the component file itself, except it has a different HTML extension. We just copy-paste inside this file the template itself, and now we just need to apply it to the component. To do so, we go back to the component file, and instead of using template, the inline template, we are going to use the template URL property. As we put the template in the same folder as the component itself, we just have to type in here the file name of the template. This will work just like this, transparently, if you are using, for example, the latest Angular CLI. If that's not the case, then you really have to give Angular some more information on how to find the template file. If you are using a CommonJS compatible module loader like, for example, System.js, you will have available at runtime a variable named module. You can take it and use module.id, pass it to the component via the module ID property, and Angular will know how to find the template. To avoid TypeScript errors, you need to declare the module variable. Again, if you are using the CLI, you don't need this module.id variable. So it's one of the many advantages of using the CLI. So this covers how to handle HTML templates in our components. Let's now see how can we add styles to a component and what is the big advantage of doing it the Angular 2 way. Stay tuned, it's coming right up. Welcome, this is Vasco from the Angular University, and in this lesson we are going to learn how to style Angular 2 components. We are going to learn what is the big advantage of styling components the Angular 2 way. We could always style a component by adding simply a link tag to our HTML page. That would work perfectly with Angular 2 without any problem. But Angular 2 introduces a new improved way of doing CSS. Let's have a look at it. The way that this works is in each component we can define styles that are specific to the component. So we have a styles property that takes on an array. This is an array of strings. Each string is just an extract of CSS, so let's just add some CSS to this component. If we add here some CSS as part of this styles array and we refresh the page, we can see that the CSS got applied to the component. But let's have a closer look to see how this was done. The styles were actually added as a style tag in the head of the page. We can see here that the styles are applied to the component, but notice this property with a randomly generated name that gets associated to the component. All the styles reference this attribute here. This means that these styles have a very high degree of specificity, because they all have an attribute in it. This causes these styles to take precedence over almost any style that you might want to apply in a page. Compared to the specificity of most commonly used libraries like styles in Bootstrap, etc., these styles would take precedence. So this mechanism is a way of partial style isolation. We can define styles that in the vast majority of cases will take precedence over any other style on the page. But the component is not really fully isolated from a style point of view. It's still inheriting, for example, fonts from the main page. If you are building an Angular 2 component, it's better to use the styles property to define the CSS of the component. This means that, for one, the styles of the component are guaranteed to not interfere with the styles in the remaining of the page, because they are based on this randomly generated property. Also, it's much less likely that styles on the page will override this style, meaning that the component will be reusable in a larger number of situations. We can also define CSS styles in external files in a very similar way to how we did it with templates. We simply create an external file which has the same name as the component file but a different extension. in this case CSS. What we're going to do is we are going to copy the CSS inside the file, and we are going to add this file, associating it to the component via the styles URLs property. Notice that this is an array, so you can pass in several CSS files in here. So we now have some basic notions of how to set up a component. We can define its template, we can define its styles, and we can define the component class. What we're going to do now is we are going to tie all these concepts together with the notion of inputs and outputs of components. We're going to build a more complex example where several components interact with each other. It's coming right up in the next lesson. Hello everyone and welcome. This is Vasco from the Angular University, and in this lesson we are going to go through a more complex example of how to build components. We are going to build multiple components and we are going to make them interact. We are going to build custom component events. So let's get started by doing a demo of the final result. So this is the final result. You have here a couple of components. One is a color picker where you can click in one of the red or blue sections and a color will be chosen. The color is applied to the title, pick a color, but it's also passed as an event to another component that is interested in receiving that event, which is the color previewer. So if we click in one or the other color, the color previewer will update its color accordingly. So let's get started by building this example. Let's start by building the color picker component. Let's start by defining a class, color picker, and we are going to define a selector, which is color-picker. We're going to define a template that for the moment has only some static HTML on it. So we are going to create a div with the class color picker, and we are going to add the two divs for the color samples. Let's now try this initial version of this component, which currently does not have behavior. We are going to add the color picker component to the list of declarations of the root module of our application, and we're going to use the new color-picker HTML element in the template of our main application. If we try this out, we can see that the template is being applied correctly. What we want to do now is to implement the color picker component. So we are going to add it a color variable, which contains the color that was just selected. We're going to make it an input of the component using the @input annotation. Next, what we want to do is we want to use this variable to color the title of the color picker. For this, we are going to use the ng-style directive, and we will be covering this directive in detail in a future lesson, but right now we are simply going to use it to determine the color of the title. Here we pass to ng-style a JavaScript object. It has one property named color. The value of that property is the value of the color variable of our component. Let's try this out to see if this is working. So if we pass into the color picker component, we pass it in a variable color with value red, we would expect the title to become red. Let's quickly try this out. So as we can see, everything is working as we would expect. Let's now implement the behavior part of color picker. So whenever we click in one of the divs, we want to emit an event saying which color was chosen. So how can we do that? The first thing that we need to do is we need to detect a click event in one of the divs, and we do so with the template syntax for events with normal braces. So we detect a click on a div, and we're going to call a component method named choose. Now we are going to pass it in the color that was chosen. We have here the two CSS colors that are available defined in this constants file. Let's then use these two constants to implement the choose behavior. So what we're going to do is whenever choose is triggered, we're going to pass in the color that was just chosen. Now inside the choose method, what we're going to do is we're going to emit the chosen color as a custom event to the outside world, to any users of this component. So To do this, we need to create a component event emitter. We do that with the event emitter class. We create a new instance of it. And we are going to assign it to a variable named color output. In order to trigger a custom event, we just need to call emit on the event emitter and pass it in the value that we want to emit, which is the new color. There is one final thing that we need to keep in mind. To the users of this event, we don't want them to subscribe to the color output event. That's the name of an internal variable. We want the subscribers of this event to subscribe to the color event. And that's why we need to put color as a string inside the @output annotation. Let's now subscribe to the color event. So we do so by using the same syntax that we have used to subscribe to standard DOM events, such as click. When a new event occurs of type color, we are going to call a onColor component function, and we're going to pass it in the color that was just chosen. This value is available via the $event Angular2 template variable. If we use this variable, we can print to the console the color that was just chosen. Let's try this out. So if we click here in a color sample and we see what's in the console, we can see that the color was outputted as expected. Let's now implement a second behavior of this component interaction example, the reset button. So whenever we click this reset button, we want the color to be resetted, for example, to black. So how can we implement this? Let's start by implementing a reset functionality at the level of the color picker component. So if a reset publicly available method is called, we are going to emit the color black. Now, how can we use this in our main component? We can create a reference, a template reference to the color picker with #picker. So because this reference is applied to an element which is not a standard DOM element, such as a div for example, the reference will become the Angular2 component itself. So we can use the reference on the click handler of reset to call directly the component reset method. If we now try this out, we can see that whenever we click on reset, black gets applied to the color picker as expected. Let's now implement the last component of this example, and we're going to see an interesting way of making components interact. Take a look at this. We're going to implement the color previewer component. This is a very simple component that takes as input one color, a color variable, and we are going to simply use that variable to output it to a text title. Like before, we are going to apply the color by using the ng-style core directive. We now need to apply the color previewer component and add it to the module of our application in order to be able to use it in our application templates. Let's quickly try out this new component to see how it works. So if we add it to the template using the color-previewer HTML element, we can pass it in, for example, a constant color of red. Let's see if this is working. So if we try this out, we can see that the color previewer is working as expected. What we want to do now is we want to make the two components interact. So whenever a color is chosen in the picker, we want to apply it to the previewer. A first way of doing this, and we're going to see a better way in a second, first way of doing this is taking the color output that comes from the output event, and we're going to assign it to a variable, and then we pass on this variable as an input for the color previewer. There is actually a better and maybe more declarative way of doing this. Let's have a look. If instead of storing the output of the event in a local variable, we instead create a reference to the previewer using #previewer, what we can do is we can pass in the output of the event of the picker directly to the previewer. With this, we no longer need the color variable actually, so we can remove it, and we have here a more declarative implementation. So you need to strike a balance here. There's more logic in the template, but at the same time we have not created variables that can be mutated and could be a potential source of errors. So depending on the concrete case, you might want to apply this technique or not. And so there we have it. This is the basis of Angular 2 components. By using a set of simple concepts like component inputs, outputs, custom events, template references, we are already in position to create a wide variety of Angular 2 components. Let's try this out with an exercise in the next lesson. Hello everyone and welcome! It's Vasco from the Angular University, and in this lesson we are going to do the exercise for the Introduction to Angular 2 Components section of our course. So let's get started. We are going to implement in this exercise a component which is the color sample component. Let's demonstrate the intended behavior. So we have here an input box that belongs to the main application template. Whenever we type in this box, we are going to see if the color is the valid name of a color. If it's so, that color should be immediately displayed in the color sample component. So we need to detect changes in the input box. I suggest to use the keyUp event. Then we need to implement this color sample component. We need to apply the color to the template. I suggest that you use, for example, ngStyle. So this is the goal of this exercise, and in the next lesson we are going to go through the solution. Hello everyone, how's it going? Vasco here from the Angular University. This is the solution for our Introduction to Components exercise. So it's the end exercise of this section. There will be a similar exercise at the end of each section of these Angular 2 courses. So let's get started implementing the color sample component. What we need to do is we need to add it an input variable color, and we need to simply apply it to the template. To apply the color to the template, let's simply use ngStyle, and we're going to set the background property of the div. We're going to assign it a color variable that we are going to add to our component and annotate with the @input annotation. With this set, we can now implement the main behavior of this exercise. So we need to detect on the input box the keyUp event. What we want to do is, whenever a keyUp event occurs, we want to assign the value of the input directly to the color variable. We create a reference #sample, a template reference, and we use it to assign it to the color property of the sample component. So we do sample.color equals, and now we need the value of the color, the current value. To get this, we create a second template reference #input to get a reference to the input box itself, and we use it to retrieve the color using input.value. And that is all that is necessary to implement this behavior. Let's try this out. If we type in the input box, we can see that the color is immediately applied to the sample as expected on each keyUp. We are going to deep dive into components in a later stage of these courses, but right now this gives us an introduction to get started with Angular 2. Next up, we are going to do a similar section introducing Angular 2 directives. It's coming right up. Hello, how's it going? It's Vasco from the Angular University, and in this lesson we are going to learn how to build our own custom Angular 2 directive. It's coming right up. So you might have noticed while coding in plain HTML that there are certain attributes that we add to elements that add or remove existing functionality to those elements, such as, for example, the required attribute that marks an input field as mandatory in a form. In this lesson we are going to learn how to build such a custom directive, again extending the standard functionality of plain HTML with our own custom functionality. This is what Angular allows us to do. The custom attribute directive that we are about to create is the collapse on click directive. Whenever we apply it to an element on the page, that element, once it's clicked, will disappear from the screen. So This is just an example, and the directive can be applied to any element on the page, including to Angular 2 components. A directive in Angular is simply a plain JavaScript class annotated with the @directive decorator. In there, we're going to pass it a selector, and notice the square brackets. This means that the directive should be applied to any HTML element on the page that has a collapse on click attribute. It is a best practice in the case of attribute directives to always use attribute selectors instead of, for example, element selectors like we do so for the case of components. Please be sure to check the end of this section for the exercise where we're going to present an implementation of collapsible that uses more features. Right now we are simply going to define a CSS selector that says the following: any collapsible section inside a collapsed element should not be displayed on the screen, so display none. Be sure to check the section on ngIf. So this directive will work in the following way. We need to detect clicks on the element on which the directive is applied to, and that is known as its host element, the directive's host element. In this case, it's this div with the CSS classes of card and card strong. Next, what we want to do is, whenever that click occurs, we want to add or remove a collapsed class to the host element, and that will trigger the appearance or disappearance of the collapsible panel. Let's see how to do this. Let's first create a isCollapsed private variable in the collapse on clicks directive, and what we're going to do is whenever a click event occurs in the host element, so we are going to use the @hostListener decorator to detect events in the host element. Whenever a click occurs, we are going to toggle the value of the private variable isCollapsed, which has a default initial value of false. What we want to do now is add the collapsed CSS class to the host element depending on the value of the isCollapsed private variable. For that, we are going to use the host binding decorator. The host binding decorator allows us to write to properties of the host element. So in this case, what we want to do is we want to set the property class.collapsed in case that the property isCollapsed of the directive is set to true. So let's now see our first custom directive in action for the first time. If we now inspect the HTML, we can see that, for example, when we click on the "this page section is collapsible" text, whenever we click on it, the CSS class collapsed is either added or removed from the host element where the directive was applied. As we can see, directives have the potential of giving us more reusable functionality compared to components. Any functionality that we add in a directive, we can add potentially to any component. But directives are really not that different from components. Let's have a look why in the next section. Hello everybody, welcome. This is Vasco from the Angular University, and in this lesson we're going to learn that components are actually just simply directives. That's right, a component is nothing more than a directive. All the functionality that you learn about components so far, like being able to pass them inputs, receive outputs, all of that functionality is also applicable to directives. Let's have a look at this in action. For example, in our collapse on click directive, let's pass it in an input property collapsed. We can use this, for example, to initially set the collapsed state of an element. Directives, just like components, also support output events. For example, in this collapse on click directive, we can subscribe to, let's say, a collapsed event and trigger an onToggle method whenever the event occurs, just like in a component. In order to implement this, just like in the case of components, we simply use an event emitter inside the directive. So we're going to create a collapsed output event emitter, and whenever a click occurs, we're going to emit a new event. Notice that inside the output decorator, we have specified the name of the event in the directive API to which the user can subscribe to. In this case, the name of the event is collapsed and not collapsed output, which is the name of the event emitter. If we now try this out, we can see that everything is working as expected. So whenever we click the panel, we can see that the panel is being toggled, collapsed or expanded, and that logging statements are showing on the screen. We are going now to present a new feature of directives, which also applies to components, which is the ability of the directive to export itself into the template on which it's being used under a form of a name. So for example, the collapse on click directive, we would like to get a reference to it. We're going to assign it the collapsible template reference. This comes from inside the directive, as we will see in a moment. We can use this reference, collapsible, directly in our template in order, for example, to add a CSS class collapsed if the Boolean flag collapsed is set to true. We can set up the collapsible reference in our directive by using the export as property of the directive decorator. In this case, we're saying that export as collapsible. So export this directive under the template reference name collapsible. You can see why this would be useful. It's in situations where you have multiple directives applied to the same element, which could be an Angular 2 component or a plain HTML element, a standard browser element. This would allow us to have 3 or 4 directives applied to the same element, each one adding its own functionality, and we would still be able to directly access those directives and their public API in our template if we so wanted. And so here we have it, our first Angular 2 custom directive. Angular 2 also comes with a lot of directives out of the box. We are going to explore what is available to us in terms of standard directives in the following sections. Then we're going to do a more complex example to put everything that we have learned in practice together. And after that, we are going to do an exercise where we are going to improve this directive, the collapse on click directive. So stay tuned. Welcome. Let's go over ng4 and its standard functionality. There's one thing that you might not have realized about it in the end of this lesson. Let's use it to display a collection of superheroes on the screen. For that, let's use the star ng4 syntax. What this syntax does is that it marks the element on which it was applied and its contents as being a template. This template will be repeated multiple times. The let keyword is used to declare a local variable hero, which is only visible inside the template. ng4 has a series of utility variables, and the first one that you are going to see is the index variable. So we can assign the value of index to a local variable, otherwise we won't be able to use it, and we can output it to the template. This local variable is only visible here. There are a few more utility variables in ng4 useful for styling. For example, there is also even and odd that is typically used to style tables. To use them, you also need to assign them to local variables using the let keyword. This won't work if you try to use them directly. Similarly to even and odd, there is also first and last that work in an equivalent way. Let's learn about trackby. This is an optimization aimed at improving the user experience of the application when we are dealing with lists with a very large number of elements. If we don't use trackby, then each time that we pass a new list to the ng4 directive, the whole list will be re-rendered on the screen. And this is not ideal for the case of large lists due to performance reasons. With trackby, we can tell Angular how to uniquely identify each row. Like that, certain optimizations can be made. For example, if the ID is new, then Angular knows immediately that it needs to render this element. Here we are passing to trackby the expression hero.id to uniquely identify the element. Notice the use of the Elvis operator. This is necessary, otherwise you will get a type error. Instead of an expression, we can also pass track by a function. Let's refactor this to use the track controller function instead. And now, one interesting thing about ng4 and a couple of tricks about components. Let's make the heroes component configurable. We can pass it a list of hero tags. Let's add a new hero, Green Lantern, so that we have a difference towards the previous list. Now let's see how the hero configuration element is implemented. Notice the @directive annotation instead of @component. This is one of the uses of @directive to create configuration elements. Another use is to create attribute directives, as we are going to see in a later lesson in this course. Now this is really cool about ng4. It will accept any implementation of iterable that you pass on to it. It doesn't have to be an array. In this case, let's use @contentChildren to inject inside the heroes the list of hero configuration elements. We can pass this heroes variable directly to ng4 because query list implements iterable. Welcome! Let's learn how to style components. We have here a heroes component, which is a configurable component that can be configured using the hero element, which is implemented with a directive. The hero directive receives a Marvel property, and we are going to style the hero differently according to this property. Let's start styling superhero rows. If we are adding only one style, we can use the plain input property syntax to write to the style DOM property. So in this case, let's write style.color equals red as a quoted string. So remember, we are simply writing to the style DOM property of the DOM element corresponding to the table row. This is a valid approach if we are changing only one style, but an alternative is also to use the ngStyle directive. With it, we can pass it an object whose keys are the CSS styles that we want to modify and whose values are the value of the corresponding style. Here we are passing it a string constant, but this could be any JavaScript expression. ngStyle also takes any JavaScript expression, so we can use it to retrieve a variable from the controller containing an object with our styles. Let's make styles a calculated property and implement it with a getter. The object containing the styles can contain any number of styles. Let's go over ngClass. We are going to apply the Marvel CSS class to all Marvel heroes, and we are going to apply the Hulk class, well, to the Hulk. First, notice that we can still use the input property syntax to add a single class. So in this case, we're going to add the Marvel class if the hero has the Marvel flag set to true. As we can see, the Marvel class has been applied correctly. Let's now use the ngClass directive by passing it in an object literal. The keys of the literal are the CSS classes that we want to add or remove to the element, and the values are JavaScript expressions that should return a boolean. If true, the class will be added to the element. Besides an object literal, we can pass into ngClass any JavaScript expression as long as it returns an object. Let's refactor this and call a classes controller method that will return an object with the classes that we want to add or remove. Like in the case of ngStyle, we can have here any number of classes. Welcome everybody. Let's talk about ngIf. We have here a panel named toggle me that we want to toggle by pressing this button named show. When the button is clicked, a toggle show controller method is triggered that toggles the value of the show boolean property. Let's now use it to pass it to ngIf. So we use the syntax *ngIf and we pass it an expression that should evaluate to a boolean. So if the boolean is true, the toggle panel will be displayed, otherwise it will be hidden. If we now click the button, we can see that the toggle me div is hidden or displayed again. Let's inspect the HTML to see how this works. You can see here the toggle panel. When we click it, it completely disappears from the DOM. If we click again show, it will be displayed again. So this is how ngIf works in general. It completely adds or completely removes elements from the DOM. Most of the times this is exactly what we want. And when in doubt, you should always use ngIf when compared to other methods of showing and hiding elements. For example, another way of doing it is via the hidden DOM property, but it's not the same thing. Let's add a second button that when clicked, it will toggle the hidden DOM property. Let's use the input properties template syntax to write to the hidden DOM property. Now let's see what happens when we click the hidden button. As we can see, the div still hides and shows like the case of ngIf, but if we inspect the HTML, we can see that when we click the hidden button, the toggle me DOM element is not removed from the DOM. Instead, the CSS display none property is assigned to this element by the browser. This is a browser functionality that will assign display none to any element with the hidden attribute. This means that the element is still present in the DOM. If this is a large element, we will pay the performance penalty of having it in the DOM, even though it's not visible to the user. Hidden might be a valid option if, for example, we have an element with a high construction cost and we want to prepare it in advance so that it's ready to be displayed to the user. This is a corner case and not the common scenario. The common scenario is we should use ngIf. We are now going to add a third button that will toggle the CSS visibility property. So we will add here a property, visibility. We are going to set it to visible, and we are going to add a toggle visibility controller method that will toggle the visibility property between hidden and visible. Let's now write to the visibility property of toggle me using the input property template syntax. So style.visibility equals the visibility property. If we now click on the visible button, we can see that toggle me is still hidden and shown as before, but with one big difference. The space that it occupies on the page is still there even though it's hidden. This is the normal functionality of the CSS visibility property, which in some cases is very useful. As a general guideline, we should try to use ngIf as much as possible. But with this lesson, we are aware that there are two other options that might be useful in certain use cases. Welcome! Let's talk about directives, also known as attribute directives, also known as decorating directives. It's a mechanism for adding functionality to existing components or existing plain HTML elements. Components are so powerful that we tend to use them for almost everything, but we should always be on the lookout for the possibility of extracting certain functionality from components into attribute directives. These will make that functionality much more reusable. For example, take a look at this tab container component. We're going to implement it not as a component, but as a series of three intercommunicating directives. This is our starting point, a plain HTML page with no functionality. As you can see, when we click, nothing happens and all three tabs are shown. We are going to make the tab panel functionality generic by saying that inside a certain part of the page delimited by the show1 container attribute directive, there are several elements decorated with the show1 directive that are only visible one at a time. Each one has an ID. Which one is visible? That is determined by the visible property of these show1 elements, and we can switch which element is visible when we click in an element decorated with the show1trigger attribute directive. We are going to identify which show1 element is active and which show1 trigger element is active using the active property on each. Under the form of directives, this functionality becomes a lot more reusable. We can take it and apply it to other components, such as, for example, a wizard, where the same situation occurs. We only want to display one element at a time, the wizard panel, and we want to be able to trigger activation based on previous and next buttons. First, let's implement the show1trigger directive, which takes as an input an ID, Superman, Batman or Flash, and an optional active flag. Let's pass in the ID using @input and let's bind it to the show1trigger attribute property. Let's also pass the optional flag, giving it a default value of false. Directives can interact with the element on which they are applied, and this is known as their host element. In this case, we want to add a click listener to the host element of show1trigger. We're going to use the @hostListener annotation for that. In this case, let's just log to the console whenever a click occurs. Now let's see this in action. If we open the console and we click in one of the tab buttons, we can see that Hello World is being logged to the console. Now, the show1trigger directive needs to interact with the show1container directive. Whenever the click occurs, we want to notify the container that another show1 should be displayed. For that, let's inject the show1container directive in the constructor of show1trigger. This should only be done if the two directives are tightly coupled, which is the case here. The trigger directive needs to register itself with the container. One way of doing it is to make a call to the container here in the constructor. Let's implement the add method. We are simply going to push the trigger into an array of triggers. A better way of doing this will be shown in a moment. Let's now implement the functionality of showing a tab panel when a tab button is clicked. What we want to do is notify the show1container that if the trigger with ID Batman is clicked, then the show1 element with ID Batman should be shown. We can see here Typescript helping us out. Show1container is not a show1trigger property. That's because we injected it in the constructor, but we did not assign it to a property. Let's do that and also mark it as private using the private keyword. To implement the show functionality, the show1container needs to have a reference to its show1 children. For that, let's inject them here directly using @contentChildren. The query list is dynamic, meaning that unlike the case of manually populating the triggers array, this list will be kept up to date. If a new show1 element is added to the page, that will eventually be reflected back to the list. In order to implement show, let's loop through the items on the list. We are going to set the item with the ID that we just clicked as active and the other ones as inactive. Let's add the ID property to the show1 directive. We can see here in the HTML that it's being passed using the show1 property. So let's use @input to link the show1 HTML property to the ID controller property. Let's now show or hide a panel to the user depending on the value of its active property. To implement this, we are going to use the hidden DOM property. Check the lesson on ngIf to understand why it would be better to implement this by completely adding or removing the whole panel from the DOM. Let's use the host binding annotation to write to the hidden DOM property of the host element. So the hidden property will be true if the active flag is false, as we can see here in this getter. Notice that we need to use the string hidden in the host binding annotation to specify that the output of this method should be written to the hidden host DOM property. This is not done automatically based on the name of the method. Let's see what we have so far. As you can see, only the active panel is being shown, and when we click on the tab button, the corresponding panel gets displayed. Let's now mark the active tab button as active. For that, we're going to use the host binding annotation to add the selected class to the host element if the flag active is set to true. We can now see the Superman tab button marked as active with a white background, but when we click on the other tab buttons, they do not get marked as active. Let's implement this final feature of our tab container. What we want to do is, whenever show is called, we want to loop also over the triggers and mark the one with the ID that was just clicked as active and the others as inactive. We have now a working tab container. As we can see, the directives functionality, just like components, is extremely powerful. Let's keep this in mind while building our components and search for opportunities to extract functionality into directives, where it can be reused across multiple components. Hello everyone, it's Vasco from the Angular University. Welcome. This lesson is the exercise for the Introduction to Directives section. What we're going to do is we're going to improve the collapse on click directive. What we want to do is the following. Take a look at the collapsed member variable in the app class. There is also another flag inside the directive, isCollapsed. What we want to do is we want to refactor the app class and the directive itself so that there is only one flag inside the directive that says if the element is collapsed or not. Then we are going to use that flag in the template of the app class by exporting the directive. We're going to use the information if the directive has the flag collapsed set to true, and we're going to use the core directive ngIf to collapse or expand the section that we want to toggle. In summary, what we are looking for is for the following improvements. Refactor both application and directive so that there is no duplicate state, and use ngIf instead of display none in order to show or hide an element, and try to make the directive as reusable as possible. Let's have a look at the following lesson for the solution. Hello everyone, it's Vasco from the Angular University. Let's start with the solution for the exercise of the Introduction to Directives section of our course. So let's start by deleting the state variable collapsed in the app class. We're not going to need it. We're not going to use input and output events in this case for implementing the collapse on click directive. We are not going to use this CSS class that uses display none either, so let's just delete that. What we're going to do is we are going to take the reference collapsible that gets exported from the directive into the template where it's being used. We're going to use it to pass the collapsed flag to ngIf. So using ngIf, we can say that the section, collapsible section, so the section that has the CSS class collapsible section, is only displayed if the collapsed variable is false, meaning that it's expanded, so it should be shown. Since we're at it, let's also use ngIf and the collapsed member variable of the directive to toggle the arrow up and down. If we try now this out, we can see that everything is still working as expected. The end result of our refactoring is a cleaner directive collapse on click. The state saying if the section is collapsed or not is contained inside the directive and it's managed only by the directive, but we can still use it easily in templates that use collapse on click via the export as functionality that allow us to create a template local variable in the consuming template. Note that the directive can still take as input the value of the collapsed flag. This allows us, for example, to set an initial value to that flag, depending on the situation. We can also still subscribe to collapsed events in case that we want to do something in reaction to the collapsing or the expanding of the panel. And this concludes our section on Introduction to Directives. We have now introduced two main building blocks of Angular, components and directives. And we have seen that they are really a way to extend the browser functionality to create our own custom elements and our own custom attributes. What we're going to see now is the third building block of Angular, services. Where does our data come from? Coming right up in the following lesson. Welcome! Let's get started with the first template syntax feature, properties. Okay, so let's grab an example to get us going. Take the following color sample div. So this is not an Angular component, it's just a plain div, okay? So this div, like any other document element, has an associated DOM element. And let's see what that looks like. Okay, so we click the element and we switch to the console and we output the variable $0. Okay, so $0 is a Chrome console feature that prints the last element that we clicked in the elements panel, okay? So it looks, we can see here, it looks like we are just printing the HTML tag, but this is actually the DOM element itself. In order to prove that, let's manipulate the color of the div via the style DOM element property. So style.background equals blue. So as we can see, $0 is the DOM element, as we've mentioned. So there are numerous DOM properties like style and many others that allow us to do all sorts of useful things. Let's now change the color of this div by using the Angular properties syntax instead. So using the angle bracket notation, we set the background color to red, we refresh, and the div is now red. So as we can see, the template property syntax can be used as a generic mechanism for reading and writing to DOM properties. So let's now see what else we can do with it. Let's now, for example, use it to disable a button. Let's just add a button and set the disable DOM property of the button to true. Now what's really important to realize is that the disabled property is not an Angular specific mechanism, okay? So this is a native DOM property and we are just using the template mechanism to write to it. So if we now refresh the page, we can see that the button is now disabled. So everything is working as expected, but there's something else going on here. To see it, let's now use the property syntax to make an input field mandatory. So we create an input field and we mark the required property to true. If we now refresh the page, we can see that the input is marked as mandatory. But this time, let's inspect the HTML. So as we can see, the input now has a required attribute. And we might be led to believe that it was the template syntax that added this attribute to the HTML tag, but that was not the case. So what happened here is that we did write to a DOM property, but for certain properties, like it's the case of required, the browser will keep in sync an HTML attribute with the corresponding DOM property. We can also use the property mechanism to hide elements using the DOM hidden property, although as we will see, we should prefer ngIf. So if we refresh the page, the div is hidden as we would expect. And these are only a few examples. With this mechanism, we have access to any of the numerous DOM properties that browsers make available. Now, what happens if we write to a property that is not used by the browser? Let's try it. We create a div and we write to a property that is not a native DOM property. So, as we can see, Angular now throws an error. This is because we are writing to a property that won't be read neither by the browser nor by our application as a component input, so this is most likely an error, maybe just a typo. Interpolation is what allows us to bind our controller with our view. With this double curly syntax right here, let's just use it to output a string. As we can see, it's very easy to use. We can use it to output directly controller variables. Let's just create a controller variable message and output it inside this interpolation block. As we can see, it's very simple to output controller variables to our template. We can use in general inside an interpolation block any valid JavaScript expression as long as it's an expression and not a statement. For example, this would evaluate as expected to true. Because we can use any valid JavaScript expression, you can also use the JavaScript ternary operator. Let's give an example. We add a controller variable condition, set it to true, and now we can use it inside an interpolation block. So if the condition is truthy, we will output the string truthy, otherwise we will output falsy. Of course, when we refresh the template, we will see that truthy is printed to the screen. Now, we don't have to call member variables only, we can also call functions. Let's call here a calculated value function that simply returns a string. If we now refresh the page, we can see that the output is as we expected. Now, we don't have to use a function for a calculated value if we don't want to. We can use a Typescript getter and get rid of this parentheses for maybe a slightly more readable interpolation expression. What happens if we try to output a property of a variable that does not exist? In this case, VM viewModel.message. VM does not exist. As we can see, Angular throws an error. It says cannot read property message of undefined. VM is undefined. We can work around this using the Elvis operator, which is available to us inside an interpolation block. This is not standard JavaScript. As we can see, the error is gone, but nothing is outputted. The way that this works is that Angular detects that VM is undefined, and as such, it will not try to evaluate the JavaScript expression vm.message. Now, one last thing about the template syntax for interpolation. Because it's a plain JavaScript expression, actually it's even better because we have the Elvis operator available. We can give it a default value by using the JavaScript OR operator. Welcome everybody! In this lesson, let's introduce the template syntax for events and explain how events work under the hood in Angular by introducing the notion of zones. So let's get going. Let's start with something rather intriguing. Let's just create a simple example of an input box, and using a reference, we're going to output in the template the value of the input box right next to the template. So input.value. Now, try to guess what will happen when we refresh the browser and we start typing in that box. What do you think it will happen? So let's try it. We start typing and nothing happens, okay? So the view is not being kept updated with the value of the input. What's going on here? More on this later. Right now, let's just add a button with the normal template syntax. So we create a click handler for the click event, as simple as that. And inside we are just going to show a plain JavaScript pop-up to the user. Let's type again in this box to change the message, and we now trigger the pop-up. Take a look. When we close the pop-up, the message was updated. So how can it be? What's going on here? In order to find out, let's add a debugger statement to try to find when exactly the message is being updated. So now we refresh the browser and we reproduce the same situation. So let's just edit the message, trigger the pop-up again. And by the way, the source maps for the examples are working. Take a look, the pop-up is hit, the breakpoint is hit, and take a look. At this moment, the message has not yet been updated. So what's going on here? Let's release the breakpoint. If we release the breakpoint, we can see that the message is now updated. So conclusion, somehow the message is being updated immediately after our click handler finishes its execution and before the control is yielded back to the browser. Let's think about it for a second together. What's going on here? We can see here that we are at the end of our click handler. So the control will be yielded back to the browser in a moment, once we release the breakpoint. But somehow Angular found a way to update the view between this moment and the moment that the browser has again control. How can it be? Because there is no code after this point. How does this work? The view gets updated after these occurrences. A DOM event, an AJAX callback, set timeout gets triggered, set interval all the same, a WebSocket callback is called, an alert like we saw, or a prompt, and after other browser async APIs are called. How can that be? This is all made possible by a library called Zones or Zone.js, which allows to install custom browser functionality at the startup of your application. It allows to patch browser APIs like add event listener, set timeout, and add your own functionality. So the way that this works is there's a browser add event listener, the standard native browser add event listener. At startup time, we're going to keep a reference to it, and then we're going to override it, because in JavaScript, everything is overridable by design in the runtime environment. So we're going to replace add event listener with our own Angular specific version that will call the original add event listener, and it will trigger any callback that we pass to it in the same event, of course. But after the callback is executed, we are going to execute some Angular specific functionality. And what we're going to do is we are going to run change detection, and if something changed, we are going to update the view. Now, this is not the exact code that gets executed, it's just for explanatory purposes. But this explains what was going on with our example. Let's go back to our example. Now we can understand much better what was going on here. Initially, we only had the input and a message. There was nothing that could have triggered the change detection mechanism of Angular. There was no event handler, there was no AJAX callback, there was no trigger. Once we added the button, we had a trigger for the change detection mechanism. So that's why the message was being updated at that moment. Let's now see how we can use events, properties, and references together with other mechanisms to create Angular 2 components. Welcome! Let's talk about pipes. A pipe is a transformation mechanism that allows us to process our data when inserting it into the template. We will go over the standard pipes by processing the data that we have on this controller. There's one thing that you might not know about certain pipes, and without it, they will simply not work, at least in certain browsers. Let's see further on this lesson. Let's see a couple of simple pipes in action. Here we have the uppercase and lowercase pipe. So any expression passed into these pipes will be transformed accordingly. So the uppercase pipe will make hello world all uppercase. Let's see this in action. Let's introduce a couple more pipes. For example, the slice pipe. It follows the same semantics as the JavaScript slice operation. You can pass it an array, you can pass it a string. It behaves as you would expect. As we can see, pipes can be customized by passing them arguments, separated by the colon character. Now take a look at this. We are going to introduce a new pipe, the date pipe. It's for formatting dates. We can pass it in the format on which we want to display the date. As we can see, the month May has been displayed on the screen. Now take a look at what happens if we run the exact same code in the Safari browser. We immediately get an error, can't find variable, and the program crashes. So what's going on here? This happens because the date pipe, like several other pipes made available to us by Angular, are dependent on the browser internationalization API. The problem is that this API is not yet available in all browsers, and that's why we have an error in Safari but not in Chrome. The best solution is to install a polyfill. A polyfill is simply a JavaScript library that installs on the browser a missing feature that the browser has not yet available. It will at startup time detect if the feature is present, and if not, it will install itself and provide that feature, sometimes partially. If the feature is already available on the browser, then the polyfill will not install itself. What we need is a polyfill for the internationalization API. A good source for polyfills is polyfill.io. Let's add a polyfill here in the index.html. If we now switch back to Safari, everything is working again. Another pipe that also needs the internationalization API is the number formatting pipe. We can configure it with a string. In this case, 5 is the number of digits left of the comma of the number that we want to display. These will be left padded with zeros, and 1 and 2 are the minimum and the maximum amount of decimal digits that we want to display. Next is the percent pipe to display percentages. This can be configured using a configuration string that follows the same format as the number pipe. The last standard pipe that we are going to see in this lesson is the currency pipe. We can pass it a 3-digit code containing the currency, a flag stating if we should print the symbol of the currency instead of, in this case, for example, USD, and a number formatting string that follows the same mechanism as the previous numeric pipes. Last but not least, let's learn how to build a custom pipe. So for that we are going to implement the sort array sorting pipe that can take one argument that determines the sorting order. We are going to apply the sort pipe to the data array. Now let's see what the custom pipe looks like. Here we have it. We need to annotate it with the @pipe annotation, give it a name, which should be the name that we are going to use it to apply it on templates, and it should implement the pipe transform interface. This interface only has one method, transform, that takes as first argument the input data of the pipe that we want to transform, and the second argument, the arguments of the pipe, in this case if the sort order is ask or desc. Let's create a simplified version of this pipe. This is for demo purposes only. We are going to sort the array. Next we are going to detect is the sort order descending, and if so we are simply going to reverse the array. We now need to configure our application so that it knows that there is a new custom pipe. For that we take the sort pipe and we need to add it to our root module in this case. So we are going to add it to the declarations property of the module. Let's try it out. As we can see, the pipe is working as expected. Welcome! Let's go over how to debug Angular 2 applications. The first thing that you want to do is to ensure that you are running in development mode. This will enable some of the techniques that we are going to show via the console and also via the browser extension Augury. A simple way to troubleshoot certain situations is to use the JSON pipe. This is a pipe made for development purposes that allows to output the value of a JavaScript object to the screen as a string. Let's see it in action by outputting the value of the model object. We can only debug so far using this method. In order to really debug a TypeScript application, we should configure the TypeScript compiler to generate source maps. We can do so via the source map property in the configuration file tsconfig.json. Now, if we go back to our program and we add a breakpoint using the debugger statement, we will see that when the breakpoint hits in the browser, we can actually view the TypeScript code and not the generated JavaScript code. Take a look at the name of the panel, it's helloworld.ts, and we can see here the full TypeScript Hello World class. Another thing that we can do is to inspect the current state of the application using the console via the ngprobe functionality. Let's have a look at how that works. Here we have clicked with the mouse in the input field, and therefore we have assigned it the $0 variable, as we've seen in previous lessons. Now let's use $0 to extract Angular specific information to the console. We can see that there is a component instance variable here. Let's take a look to see what it contains. As we can see, it has the state of the Hello World component. So with ngprobe we can print to the console the state of any component in the component tree. Now let's try to modify the value of message to see what happens. The change is applied to the variable, but take a look, the screen has not reflected the change. For that, let's manually trigger change detection via the console. As we can see, the change that we made to the message variable has now been applied. Debugging via the console is very useful, especially in situations where we are not administrators in our machine, so we might not have Chrome available or be able to install Chrome extensions. But if we can, we have the Augury Chrome extension that allows us to inspect an Angular 2 application. We can access it here in the console via the Augury menu. We can see that Augury presents us the same information that we had via the console, but in a much more user-friendly way. Hello, how's it going? It's Vasco from the Angular University. In this lesson we are going to introduce one of the main building blocks of Angular 2, services coming right up. We have seen that our components can receive input data using the @input decorator. Now, where does that data come from in a real live application? Typically it comes from a backend. So let's take for example this small component here. It's just a list of lessons. What we have here is that this data is coming from an array, which is a constant that we have defined here. This lessons data constant contains the data that is being displayed in the browser. We can see here that lessons data is being assigned to the lessons variable, which is being passed as an input to the lessons list component. Now, typically this data comes from a service and it's not injected directly in the controller. So let's take a look at what a service looks like. Let's write our first service, the lessons service. A service in Angular 2 is just a plain class. So we are going to write a lessons service class and we're going to give it a constructor. Inside the constructor, we're going to call an initialization method called loadLessons. And in there, for the moment, we are simply going to assign the test data that we have. We are going to assign it to a lessons variable. Now, how do we use the service? In this case, we go to any place on the application that actually needs direct access to the service, and we're going to inject the service via constructor injection. In this case, we go to the app component and we're going to inject in the constructor the lessons service. Notice the use of the private keyword while we are injecting lessons service in the component. What this does is that it creates on the app class a member variable called lessons service and assigns the value of the constructor variable to that member variable. It also marks it as private, meaning that if we try to use this variable in other classes of our application, we will get a compilation error. Now that we have a reference to the service, we are going to use it in our template directly by passing the lessons data into the lessons list component using lessons service.lessons. But how does Angular know that it can inject this service in the constructor? We need to mark this class as injectable using the injectable decorator. And as any other decorator, notice that if you don't add the parentheses at the end, it will not work. What we need to do now is to declare the lessons service as being injectable in our application. Right now, this is just a plain class with an annotation. We need to pass it to the Angular 2 dependency injection system so that it's available for injection at runtime. Otherwise, we will get an error. In order to do so, we need to go to our ng module, which in this case is the root module of the application. It could also be a feature module. And we need to add the lesson service to the providers list of the module. And now we are ready to try our first service. If we reload the application, we can see that everything is still working correctly. So the data is not being injected directly in the component. This is coming via a service. Right now it's still coming from a member variable in the service, but now we can refactor this to make the data come from basically anywhere, typically our backend. We will do that in the next lesson. Hello, how's it going? Vasco here from the Angular University. In this lesson, we're going to learn how to do our first HTTP call in our lesson service. So, coming right up. Take a look at this version of lesson service. It's still retrieving the lessons data from a variable in memory. what we're going to do is we're going to fetch this data from the backend via an HTTP call, a GET call. For that, let's inject the standard HTTP Angular 2 service. So this is a service that comes together with Angular. We're going to use it to do a GET call using this.http.get. We pass in the URL that we want to hit on the servers, in this case /lessons, and let's have a look at the server. The server is just a simple Express server for testing purposes, for demo purposes. I will show you in an upcoming lesson how to set up such a server. Take a look. Once the server gets a GET, so get lessons, it's going to return a JSON object that contains the lessons data. Take a look, the lessons data is still the same data that we saw before, but right now it's going to be served by our backend. In order to get back the result from the backend, we need to subscribe to the output of the get method. The output of get is an RxJS observable, and we are going to go in detail on what that is and how to use it. Right now, we are going to subscribe to the output of get, and we are going to pass it a function. So this function has one argument, lessons data, which is the data that came from the backend. And on the body of the function, we have only one line where we are going to take the result that came from the backend, so lessons data, and we're going to assign it to the service lessons variable. Notice that we are getting here an error, and this is because what we receive from the get call is not immediately what we sent as response from the backend. What we get is a response object that has other information other than the data. So what we need to do is, using the map RxJS operator, we need to transform the response into only the data. So we do that by calling map and then response.json. This will transform the response into the output of response.json. And like that, in our subscriber method, we receive only the data, the lessons. In order to be able to use the HTTP service that Angular provides out of the box, we need to import the HTTP module in the root module of our application. So in our app module, we are simply going to add HTTP module to the imports. Take a look at the import. So this belongs to @angular/HTTP. Let's now see all of this in action. If we reload the application, we can see that all the data is still there. And if we open the network panel of our developer tools, we can see that an HTTP request was done and that we received the data from the backend. Next, what we're going to do is we're going to save some data to the server using Angular 2 HTTP and add that to our service. In the following lesson, coming right up. Hello, how's it going? Vasco here from the Angular University. In this lesson, we're going to learn how to use the Angular 2 HTTP service in order to do a post modification call to our backend server. As a bonus, we are also going to learn how to use the private keyword in the Typescript constructor in order to automatically declare a member variable for our class. So, coming right up. What we want to implement is, whenever the user types the name of a lesson in the add lesson input box and pushes enter, we are going to send an HTTP post call to our server to save the new lesson into the list. What we want to do is to detect the key up event, and in response to that event, we want to call the lesson service create lesson method, which is a new method that we are about to create now. Note that we should detect specifically the keyup.enter event, so only if the user presses enter is a request sent to the server. Now let's have a look at what the create lesson method looks like. We only have the description at the beginning of the method, so the first thing that we need to do is to create a lesson object to send to the backend as JSON. So for that, let's use the shorthand notation, curly brackets, description. This is equivalent to this, to an object with a key of description and a value which has the exact same name. So this can be shorthanded to curly braces description. So this is one of the features of TypeScript and also of the latest standard of JavaScript in general. Since we are introducing some TypeScript features, take a look at the use of the private keyword in the member variable of the constructor. This is equivalent to the following: to declaring an HTTP member variable, assigning it the value of the constructor variable, so this.http equals HTTP, and also marking the member variable as private. So all of this can be achieved with this shorthand notation for declaring member variables of a class in the constructor. So the first thing that we are going to do here is that we are going to immediately add the new lesson to the lessons list. This is an optimistic strategy where we assume that the operation on the backend is going to be successful. So we immediately add the entry to our list so that the user can get immediate feedback and does not perceive a waiting time. In the background, we are going to save it to our database in our backend, and we are going to show something else to the user only in the case that something went wrong. We would show him an error message. So with this, let's make our network call. We use http.post, which takes 3 arguments. The first argument is the URL that you want to hit on the backend, /lessons in our case. The second argument is a string containing the data that you want to send over the network. In this case, we are going to take our lesson object and we are going to transform it into a string using json.stringify. The third argument is the HTTP headers that you want to be part of your request. In our case, we are just going to populate the content type HTTP header, specifying that the content of the message that we are sending to the server is JSON. This allows the server to unserialize the payload that it received properly. With the Angular 2 HTTP service, if we don't subscribe to it, nothing happens. So let's subscribe to the output of the post call. We're going to pass it a success handler. It's this parenthesis, arrow operator, empty method body, this first line. This simply says that we don't need to do anything special if the request is successful. Remember, we already added the lesson to our lessons list in memory on the client side. What we're going to do next is to pass in an error handler. In this case, we are just outputting the error to the console. More on error handling in the next lesson. Let's now try this out. If we reload the page and we type a new lesson in the input box and we push enter, we can see that the lesson is immediately applied to the list, and on the background an HTTP request was sent and the lesson was saved on the server. If we reload the page, we can see that the lesson is still there. Take a look at what happened on our test server. We received the new lesson in the body of the post call and we can access it using rec.body, so request.body. This gives us our lesson that traveled through the wire. Now, we're just going to push it into our list of lessons in our test server. We're going to see how to make such a test server for testing and development purposes in a future lesson. Right now, let's first talk about what if things go wrong in server processing. Let's talk a little bit about error handling. Hello, how's it going? It's Vasco from the Angular University. In this lesson, we're going to learn how to handle errors using the standard HTTP Angular 2 service. So, coming right up, error handling in HTTP. Let's first, in our example, throw an error. Let's say that we are reading the list of lessons and something went wrong in the server. So we're going to throw an error. For that, we are going to use the response object and we're going to return a 500 HTTP status code. So this means server internal error. And we're going to send this directly back to the client. Notice that this call does not have any error handling. So we have a message in the console, but it's really not very helpful. Especially in a large application, this wouldn't tell us much of what went wrong. So we provide an error handler. In this case, we are just going to console.log the output of the error plus a customized message to the screen. This is something that you see a lot in real-world applications. Please don't do this. Don't do console.log. There's a much better way. What you should do is, at least in the case of error, do instead a console.error. What this will do is that this will also output the error message to the screen, but take a look at this in the console now. We have a full stack trace of the error, and we have the file name and the line number of the Typescript file where the error occurred. So if we click here, we go directly to the Typescript line where the problem occurred. This is much more helpful. In a real-world application, you would also call a messages service to display a meaningful message to the user. We're going to build one such service in one of our upcoming exercises. We are almost ready for the first services exercise. Let's just see in the next lesson how to set up an HTTP server for development and testing purposes like we did so far. Stay tuned! How's it going, everybody? It's Vasco from the Angular University. In this lesson we're going to learn how to set up a small development server for learning purposes. We simply run a node process and we are going to use Typescript to write our server. So we are going to run it using tsnode. Tsnode is a node module that allows us to run our node programs in Typescript instead of plain JavaScript. Let's take a look at our lessons server that is serving the lessons data. You will see that it's very simple. We're going to use, in our lessons server.ts file, we're going to use Express. That's the most used Node.js web framework. We're going to load a couple of Express-specific modules to allow us to receive messages in the JSON format. So now let's add some functionality to our backend server. We're going to implement a very small REST API. So further in this course, you're going to learn how to do this in Firebase as well. But right now, let's start with a very simple REST API that aims at providing lesson data or modifying it. So we're going to define the get method, the delete method, and the post method for /lessons. So as you might know, in REST, get retrieves the data. Post is like a wildcard operation. In this case, we are going to insert a new lesson, and delete is a logical delete. So in this case, we are going to remove a lesson from the lessons list on the server. In order to start the server, we simply call app.listen. We specify which port we want to use, and it's as simple as that. You have a very small development server that you can use for developing a small application without having to worry to set up a large-scale backend. So again, you could develop your whole front end against this very simple backend server, providing mock data, simulating delays with set timeout. The possibilities are numerous. One thing's for sure, please don't use this in production because we are saving data to an in-memory array, and this is really not what you would like to do outside of a development mode. But for development purposes, for trying things around, this setup is really ideal. Now what we're going to do is we're going to use this server and what we have learned so far about services to implement our first exercise. Coming right up. Hello everyone, how's it going? It's Vasco from the Angular University. And in this lesson, we are going to learn how to create our own Angular 2 module. But most of all, we're going to learn why would we want to do that, why it's useful. It's coming right up. So far, we have been using the standard Angular 2 modules, such as the browser module or the HTTP module. And we did create our own module, the application root module. But this is not the only modules that might make up our application. Imagine that you have created a set of reusable widget components. That's a good case for creating a module, because you want a set of components to be available to several parts of your application or even to several applications. Now, those components might be internally composed of smaller components that you don't want necessarily to expose to the users of your component. Such type of module is also known as a feature module. Let's give an example. In our small application, we are going to create a lessons module. This lessons module will contain one component, the lessons list, and it will contain one service, the lessons service. An Angular 2 module is simply a class, so let's write a class lessons module. In order to make it a module, we need to annotate it with the ng module annotation. The first thing that we need to configure in ng module is which components, directives, and pipes are known to this module. So we are going to configure the declarations property, and we are going to add it in the lessons list component. Next, we need to configure the lesson service. For that, we need to configure the providers property, and inside it we are going to pass it in a list of injectables that we need to add to the dependency injection system of Angular. So we're going back to our application module and we are going to remove the provider for lesson service. We're going to add it in to the module. One word of caution here, you might not always want to add providers to your module. We're going to see that in the lazy loading and shared modules upcoming lesson. Now for this concrete case, we are going to try this module out. So let's see if this is working. We are going to add the lessons module to the application module and we're going to start our application. Try to guess what happens. If we refresh the page, we can see that there is an error, and let's inspect the error. It says can bind to ng4 of. This means that Angular does not recognize the ng4 directive. And we thought, this directive is implicitly available everywhere in Angular. So how can Angular not recognize this directive inside lessons list? Because it's inside lessons list only that this problem is occurring. The reason for that is that lessons list belongs to the lessons module, and the lessons module did not import the Angular common module, so it does not know the ng4 directive. So if we import the common module, this error will be fixed. If we now try this out, we see that we get a second error. And why is that? It's because the lessons list component is not recognized by Angular. But how can it be? Because it's part of the lessons module that we are importing. The problem is we have not declared the lessons list component as being part of the public API of the module. So it remains private to the module. It would be visible inside the module, but not to any other importing parts of the application. In order to mark it as public, we need to declare it inside the exports array property. If we now try this out, we can see that everything is working as expected. Our application is working as expected and the refactoring is successfully completed. We can see how modules can be useful in structuring our application by allowing us to split it into several reusable parts. But in the lazy loading lesson of the router course, we are going to learn why that might also help us improve the performance of our application. How's it going, everybody? It's Vasco from the Angular University and it's exercise time. We are at the end of this introductory section on services. Let's further extend the lesson service in order to add the functionality to delete a lesson from the list. So the goal is to add a small button in each entry of the list to the right that says delete, and when we click it, that item should disappear from the list. What you need to do is to call the HTTP server on the backend, and you need to do an HTTP delete. You need to tell the backend which lesson should be deleted by passing its identifier in the delete call. So, good luck and catch you in the next lesson for the solution. Hello everyone, it's Vasco from the Angular University, and in this lesson we are going to go over the solution for the Introduction to Services exercise. So the first thing that we need to do is to add a delete button to each of the entries of the table, and when the button is clicked, we are going to pass to a service method the ID of the entry that we want to delete. So each lesson has an ID that uniquely identifies it. Next, we want to immediately delete the lesson from the in-memory array that we have on the client side, and for that, let's search for the index of this lesson based on the ID. We are going to use the findIndexArray method that is available in most browsers. So we are going to pass it a function that returns true if the ID of the lesson is the one that we are deleting. And like that, we have a variable named index. Actually, it is a constant, it is immutable. We cannot modify it once it's assigned. Named index that contains the index where that lesson is inside the in-memory array. Next, we are going to use the splice JavaScript array operator to remove the entry from the list. Now we are going to notify the server that we want to do a logical delete of this lesson ID. For that we call http.delete and we pass in /lessons, and in the URL we pass the ID of the lesson that we want to delete. Notice that the delete call has no body, so in this case we are only calling the function using 2 arguments and not 3 like the case of post. Notice this exagr headers function. This is just a practical way to define headers that you want to include basically in every HTTP call that you want to make to the backend. In this case, we are always going to be using JSON, and so we include the content type application JSON HTTP header. We also want to typically include x-requested-with to XML HTTP request. This will tell the server that this is an AJAX request and not a full page reload. This is sometimes useful for certain functionalities of the server, and it's a good idea to put it in here. As always with the HTTP service, we need to subscribe to the HTTP delete call. We need to provide a success handler, in this case it's empty, and an error handler, in this case simply output the error to console.error. Now, let's take a look at what is going to happen in the server. In the server, we are going to read the lesson ID from the URL using request.params. Then we are going to search it in the in-memory array of lessons that we have on the server. And this time around, we are going to use the Lodash functional programming library. Next, we are going to use the splice operator to again delete this entry from the array. And we are going to return a HTTP 200 OK status, signaling the client that the delete was successful. Next, let's try this. So if we delete any of the items on the list, we can see that they are successfully deleted on the client. Now, let's reload the application, and as we can see, the deletes also took place on the server. This concludes our introductory section of the course, where we have introduced components, directives, and services, 3 of the main building blocks of Angular 2. Now we are going to revisit each one in more detail in the following sections, so stay tuned. Hello everyone, how's it going? It's Vasco from the Angular University. We're going to see why there are several reasons throughout this video why it's a great idea to use the Angular CLI, either if you are just trying out the framework for the first time and you want a safe, stable playground as a development environment, or even if you are starting out a new project, you should at least have a look at the CLI because it might be a very good option. Let's simply install the latest Angular CLI. So the package that we need to install is called @angular/CLI, and if you are in Unix or Mac, you might have to add a sudo at the beginning of the installation command. This will take a while, but the installation will be completed. So let's just now scaffold a project using ng-new hello world. So this will take a while, but a new Angular project will be scaffolded from scratch using the latest version of Angular. And after a while, we have a new project completely scaffolded. So let's open it here. So you can see here, for example, the application module file of our application. So this contains all the modules that are imported into the project. So as we can see, everything is compliant to the latest version of Angular. Let's run the project. So here in the command line, we need to cd into the folder, and there we simply type ngserve, and this will start a development server. One of the advantages of this development server is that it has hot reloading working. Let's see this in action. So after a while, your development server is running. So if you go to localhost port 4200, let's do 4200. We have here a running Hello World application. So this is running in development mode, so it's in just-in-time compilation mode. Let's take a look at the network tab. So if we refresh the application, we can see that we only have about 6 requests and everything loads in about 1 second. So this gives a very good experience for development. We don't have a lot of HTTP requests. Now let's do a modification. Let's go to the application component. And as we can see, another advantage of using this CLI version is that we don't have to fill in here this property module ID that we need to fill in if we are using, for example, system.js, at least for the moment. So we can simply type here the relative path to the template. Let's see here in the file directory structure. So this file .html.css are right next to the component file. So we can reference them simply by using a relative path, and the CLI will be able to find these files and add them to the build transparently. So no module ID needed. Let's now make a simple change to the template. Let's simply say Angular Hello World, and we're going to see hot reloading in action. So if we save the file, that kicks in our build. It will rebuild the application bundle, and it will trigger hot reloading. So we have here the new change applied automatically. The CLI is also very convenient for developing new components and services, so it takes away all the need for boilerplate. So if, for example, we create a new component, so ngg of generate, and then we generate a component, let's call it hello. If we run this command, we are going to have an hello component generated. We have here the paths and the files that were generated. So here inside app, we have here a new component ready to use. Everything is filled in automatically for us according to the Angular style guide. So this is really very convenient for development. Another great thing about this generated component is that not only it follows the Angular 2 style guide, but also it's ready to use. So if we take the app hello selector of the component, let's simply try to add it here to the template of our application. So if we apply it directly in a template and we hit Ctrl S, this is going to trigger the rebuilding of the bundle. And we can see that the hello component was already included in the template. So the generated component is not only compliant with the style guide, but it's ready to be used because it was correctly registered here in the application module. Many other CLI commands are already available. Let's, for example, generate a new directive. So ngg directive, and here let's pass in a path, and we are going to call it my directive, or simply my dir. We're going to create the directive, and we can see here the paths where the directive is available. So here it is under the shared folder. So more commands are available for the CLI. Let's generate a pipe as well. ngg pipe, and we are going to call it my pipe. So if we run this, also here, if we don't pass in a path, it will show up on the root of the application. That might not be what is intended. So as we can see, the pipe is here. And again, all these directives, pipes, services, etc. that are generated via the command line, they are ready to be used in the templates directly. Another great thing about the CLI is that the production build is already usable. Actually, we could create a build, a development build using ng build, and a production build using --prod, and this would create a dist folder containing the build. But in order to use either build, we don't have to run ng build. We can simply run the corresponding serve command. So in this case, ng serve --prod. And what this will do is that it will create a minified, compressed bundle that is also tree-shaped. So let's take a look here at the output log. As we can see here in the log, we can see which functions were dropped in the production build. So this will reduce the size of the bundle. As we can see, the application still works perfectly in production mode. If you are starting a project today, why not start it directly with the CLI? You can see that you get a lot of productivity. You just run a command in the command line and you get a working component. So this is huge. You have a great development experience with the hot reloading, and in the near future it will be just a matter of updating the CLI and your build will still work, your application will still work. So in summary, the Angular CLI is really the ideal starting point for starting a new project with Angular.